Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on logic gates. In our last lesson, we talked about transistors. We discussed what a transistor is, and we looked at the differences between a PNP and an NPN transistor. PNP transistors are transistors with outer layers made up of P-type material and an inner layer made up of N-type material, while NPN transistors are transistors with outer layers made up of N-type material and an inner layer made up of P-type material. We identified the base, emitter, and collector of a transistor and briefly reviewed forward and reverse biased. We also described how a semiconductor diode can be used in a half-wave rectification. Today, we are going to discuss logic gates, including NAND, NOR, NOT, and OR gates. We will explain the function of each one of these gates, observe their circuit symbols, and draw the truth tables for several of them based on Boolean algebra. Let us get started. A logic gate is a small silicon chip or digital circuit that has combinations of transistors and resistors etched on it. It performs a logical operation on one or more logic inputs to create a single logical output. Therefore, it either allows an electrical current to pass or it stops it. They are called logic gates because they only allow the current to flow through them under logical conditions. English mathematician George Boole created a new form of algebra called Boolean algebra. This form of algebra deals with logical statements that only have two values: true values and false values. Boolean algebra also deals with operations, including NAND operations, NOR operations, AND operations, OR operations, and NOT operations. We are going to learn about these gates, which are representations of their operations. NAND and NOR gates are sometimes called universal gates. This is because they are the two basic logic gates that any other gates can be built from. An AND gate has two inputs that create one logical output. Thus, one input and another input equals an output. An OR gate has more than one input to equal one logical output. Typically, this means two inputs, but not always. Thus, one input or another input equals an output. A NOT gate has just one input to equal one logical output. However, with this gate, the output is always the opposite of the input. Thus, if nothing is put in, something will come out. And if something is put in, nothing will come out. Students, now that we have gone through each type of logic gate, please draw the circuit symbol for each, marking the input or inputs and the output.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to correctly draw each gate's symbol? Teacher, please go over the circuit symbol for each of these gates with the students at the end of today's lesson. There is another way to express NAND, NOR, AND, OR, and NOT operations besides using circuit symbols. You can explain the actions of these gates using truth tables. A truth table shows all of the possible inputs for a logic gate as well as all of its corresponding outputs. It is also referred to as a table of combinations for that specific gate. Boolean algebra deals with logical statements that only have two values, a truth value and a false value. The number 1 is used to represent a true statement, while 0 represents a false statement. In a moment, I will show you the circuit symbols for the AND gate again. I bet you were wondering what the table on the right side of the symbol was all about. The table to the right of the AND gate symbol is the table of combinations for the AND gate, or its truth table. You can see that the AND gate's two inputs are listed, A and B. The result of these inputs is represented in the output column. In both columns, true and false statements are shown for each possible input and output. For example, a false input of A and a false input of B equals a false output, and so on. Students, let us do another activity. Now that you understand how truth tables work, create a truth table for a NAND, NOR, OR, and NOT gate.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to create a truth table for a NAND, NOR, OR, and NOT gate? Teacher, please go over these charts with the students at the end of today's lesson. In today's lesson, we learned all about NAND, NOR, NOT, and OR gates. We learned that these gates were used by George Boole in his Boolean algebra. We saw each type of gate represented as a circuit symbol and also as a truth table. We finish by learning how to create truth tables to represent each possible input and the corresponding output for a logic gate. This is all for today's lesson. Until next time, thank you, teacher. Thank you, students.